Hey, welcome. In this video, we are evaluating only the quadrantal angles for a given trig ratio. So for example, what are quadrantal angles? In degree mode, quadrantal angles are the 0 degrees, 90, 180, 270, 360, and continues. It's the quadrantal angles, which means it comes from the word quarter. 0 degrees here, 90, 180, 270, and 360. In radian world, quadrantal angles would be 0 radians, pi over 2, pi, 3/2 of pi, and then 2 pi, and then it continues. So 2 pi will complete one rotation, and then after that it just continues. Now this is a unit circle, which means the radius of the circle is 1. The radius of the circle is 1, which means this length is also 1, that's also 1, that's also 1. So if I were to put the coordinates of every quadrantal, 1, 2, 3, and 4, the units here would have to be 1, 0, because we are 1 unit on x-axis and 0 on y-axis. Here it would be 0, -1, 0, 1. My left-hand side would be -1, 0. So those are the coordinates of the unit here. And the last one, which will be 270, the coordinates here will be 0, -1, because we are going below x-axis. Also keep in mind, this is all in reference to x-axis here, and then this corresponds to y-axis. Okay. Also, the xy coordinate grid, like we did in class, the x coordinate reflects cosine of theta value, and the y coordinate reflects sine of theta value, which means any given point, cosine of that angle could directly be derived from the x coordinate, and sine could be derived from the y coordinate. That leaves us with tangent. What about tangent of theta? Tangent is simply my coordinate over the x coordinate. If I were to make a little table for this, sine of theta would simply be y coordinate, cosine of theta would simply be x coordinate, and this only applies to unit circle. Radius has to be 1. Tangent of theta is simply y over x. Cosecant, which is reciprocal of sine, not opposite of sine, it's the reciprocal of sine, would be 1 over y. Secant, which is the reciprocal of cosine, would be 1 over x. And cotangent of theta would be x over y. And just based off of x and y, if we know x comma y, we can simply get all 6 of them based off of this table that I made in green. So let's evaluate some of them. For example, some basic ones would be, what if the question asked me, what's cosine of 270 degrees? Well, you first go to the location, which is 270 degree. The point there, corresponding point there is 0, 1. Hence, the cosine value would be the x coordinate, which is simply 0. I wrote that just to show you the corresponding point. Final answer would be 0 because that's the cosine value. That was a basic one. Let's say for the same location, I'm asking, hey, what about cosine of 3 pi over 2? Well, 3 pi over 2 is the exact same location as 270 degrees, so it's back to the same point, 0, -1, and the cosine is going to be the x value there. How does it get any harder? Well, what if we start taking more and more rotations? Well, let's say I'm saying, hey, what's tangent of 5 pi? Well, first of all, I need to find that location. So 5 pi, this is 0, that's pi. One full rotation is 5 pi. One full rotation is 2 pi. Now I'm going pi's 5 times. So that's 1 pi, and 2 pi, 3 pi, 4 pi, and 5 pi. So 5 pi back to this location, same location as pi. Once I got to the location, I'd say to myself that, well, the coordinates here are -1, 0, because I'm on the negative side of x-axis. From here, we also know, like I said in this table here, like this right here, tangent is y over x. The tangent 5 pi is y over x. Y coordinate there is 0, x coordinate there is -1, and that boils down to 0. Hence, tangent of 5 pi is 0. The idea is you got to get the location based off of rotations. Here's another example. What if I'm going tangent of -5 pi now? which basically means
Regulars, present, absent, or even start. It's time for our attendance part.
there we go. Negative pi. So I'm going in increments of pi, I'm sorry. We're going in increments of 5 in negative direction. And negative direction for angles is this direction, which is clockwise. So that's 1 pi, and 2 pi, and 3 pi, and 4 pi, and 5 pi. I went negative 5 pi's, and guess what? The location ended up being the exact same. Coordinates here are negative 1 comma 0. Tangent is still defined as y over x. So tangent of negative 5 pi is still 0 over negative 1, which boils down to 0. Both the answers happen to be the same because the location was the same. Okay, let's say now we are moving on from just sine, cosine, tangent to the other 6, the other 3. But let's say the question says, hey, what about secant of 11 pi? Well, let's secant. We'll get to the secant part later. Let's find the location first. Odd numbers, this is 0, and that's pi. Remember, all the odd numbers will end up here, and even numbers will end up here, because that's also 2 pi. Or you can just go 1 pi, and then 2 pi, and then 3 pi, 4, 5, 6, 7, 8, 9, 10, 11. Since it's an odd number, we will end up back here on the odd side, because 1, 3, 5 will end up being here. The same location as the previous question. We will get the coordinates there. And then we're like, wait a second. Secant is described as 1 over, you can see it's 1 over x. One more time, up here, secant is defined as 1 over x. 1 over x. So what's the x coordinate there? Negative 1. So 1 over negative 1, which is back to negative 1. So that's negative 1. What if we have bigger numbers? Let's say we're working on cotangent of negative 8 pi over 2. And this lesson is only on the quadrantal angles, so I'm sticking to quadrantals. This is basically cotangent of negative 4 pi. Let's find the location. 0 pi. And we're going in negative direction. 1 revolution is 2 pi, so that's negative 2 pi. Another full rotation gets me to negative 4 pi, which means it's this angle. Which means I'm going to now get the coordinates there. 1 comma 0, because I'm on the right side. And also remember, this is a unit circle. I'm not drawing that every single time, but just so you know, 1 comma 0. And then cotangent is described as 1 x over y. Cotangent is x over y. And if you don't have that memorized, you can kind of find tangent first and then reciprocal it. But I'll do x over y. And the x coordinate here is 1, y coordinate here is 0. 1 over 0. Cotangent negative 4 pi. And division by 0 is undefined in mathematics. So cotangent negative 4 pi. Or you can write undefined. Another example could be cosecant of negative 5 pi over 2. And that's my last example here. Let's find the location. And that's pi over 2. That's pi. That's 3 pi over 2. That's our 0. We're going in the negative direction. That's what that tells me. And then we're going up in halves 5 times. So this is negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, and negative 5 pi over 2. So this is the same as negative 5 pi over 2. Why? Because we were going in increments of pi over 2 5 times. That's another way to read it. We're going in increments of pi over 2 5 times in the negative direction. Once I got to that location, the point here is, the coordinate here is 0, negative 1. Cosecant, I'm going to first find sine there. Sine value is negative 1. All I have to do is reciprocal negative 1. And the reciprocal of negative 1 basically is the same thing, which is same as negative 1. So this is negative 1. If you've noticed, all the answers to these questions were either 0, 1, negative 1, or undefined. One more time, 0, 1, negative 1, or undefined. Yeah, all the quadrantals is going to be one of these answers. Alright, that was it for quadrantals. See you in the next video. Bye.